Okay, just to kind of make sure that we're ready to go on Thursday, we're going to kind of spend a little bit of time reviewing simplifying radicals. Again, this is something that you should have done in Algebra 1, you would have done in geometry, and then now we're again going to do it in Algebra 2. So remember, there are three basic rules for any sort of radical. 1, never leave a perfect square inside of a radical. 2, never leave a radical in any denominator. And then never leave a fraction inside of a radical. That includes decimals. Decimal is the same thing as a fraction. So if we have, first off, never leaving a perfect square in a radical. So hopefully if you need, or you should remember that some of my perfect squares are 1 and 4, 9 and 16, 25 and 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and then 400. So those are the first 20. That's for the most part what you'll need. You'll use those, basically you'll use those to simplify. So what I always suggest is whenever we simplify, always look for the bigger number. So and kind of work through your list as far as what numbers I can divide. I never want to start with the smaller numbers. I always want to start with the biggest number possible. So like if I have the square root of 50, I'm basically going to start at 49 and kind of weave my way back up through my list. So I can't divide 50 by 49. I can't divide it by 36. I can divide it, however, by 25. So what I'm going to do is I'm going to break it up as the square root of 25. I always write my perfect square first and then multiply that. So 25 times 2 gives me 50. So the square root of 25, it's the fifth number, so 5 squared. So it's going to be 5 times the square root of 2. Doing the same thing with the 20. So with the 20, if I take it and let's fix the 9, there we go. So 20 is going to basically, the next number in my list of everything is going to be 16. So I go from 16, I can't divide it by 16, I can't divide it by 9. I can, however, divide it by 4. So I'm going to have the square root of 4 times the square root of 5. So square root of 4 is 2 times the square root of 5. Same way then on 150, I'm going to go through my list. I'm going to start down here at 121. I'm going to go to 100, no, 81, no, 64, 49, 36, 25. Okay, I can divide it by 25, or I can factor out the square root of 25 and do it again, and that is going to be times the square root of 6. So square root of 25 is 5, so 5 times the square root of 6. Now, same thing, if I have 2 times the square root of 45, I'm going to go the same thing with my list, and now I have a number out in front. That is okay. I'm just going to have the 2 still out there in front. I'm going to break up my 45, so I'm going to have 2 times. I can divide it or break up the 45 as the square root of 9 and the square root of 5. Square root of 9 is 3, so I have 2 times 3 times the square root of 5. So my final answer is just going to be 6 times the square root of 5. Now, on one like this over here to the right where I have 2 times the square root of 15 times 5 times the square root of 30, you can do this a couple different ways. One way that I would suggest is you can either put it together, since 15 and 30 don't have perfect squares in them. Okay, what I would do is, or what you can do, is multiply the 5 and the 2. Okay, so I have 10 times, and then multiply 15 times 30, which is going to give me 450. Okay, now if I had numbers that would work, that did have perfect squares, then I would actually break it up that way. But since I don't, I'm going to put it together and make one radical, and then go through my list. So as I go through, I'm at 400, 361, so on and so forth, and I get down to where I have 10 times the square root of 225 times the square root of 2. So the square root of 225 is 15, so I'm going to have 10 times 15 times the square root of 2. So 150 times the square root of 2. Same way, okay, now even though I have the square root of 25, well, that's a perfect square. Square root of 9, that's a perfect square. So this is going to be nice and neat, and it's just going to be 2 times 5 times 5 again times 9. Or times 3, excuse me. So 2 times 5 is 10, 10 times 5 is 50, 50 times 3 is 150. If everything goes away and everything's a perfect square, it's just going to be that number. All we're doing is multiplying. Okay, so don't overcomplicate it. Don't make it 25. It's 2 times 5, because it's 2 times the square root of 5. Okay? If you needed to combine it and you needed to do 225 times 9 and get 225 and take the square root of that, it would all work out. So now with the second rule is going to be you never leave a radical in the denominator spot. So we have to rationalize it. So whenever we rationalize this, we're going to have 3 over the square root of 5. So what you're going to probably want to do to start is see what number can I make that's a perfect square. So if I multiply, I'm really just changing how it looks. Okay, I can't leave a radical in the denominator. Okay, all the square root of 5 over the square root of 5 is 1. So it's really like I'm not changing the value. I'm just changing how it looks and how everything is kind of represented. So I'm going to multiply straight across on the top. So in doing that, I have 3 times the square root of 5 over the square root of 25. Now, as you get better with this, hopefully you start to see a trend. Square root of 25 is just going to be 5, and it's going to be on the bottom. Notice that whenever I multiply 2 square roots by the same value, okay, that's underneath, that it's just going to be that value. 3 times the square root of 5, and I'm done. Do not, whatever you do, do not try to cancel the square root of 5 and 5. They are completely different numbers. The square root of 5 is about 2 point some random decimal, and then 5 is 5. So, second one, 3 times the square root of 7, all over the square root of 10. If I can, so I'm going to take square root of 10 over the square root of 10. So I have 3 times the square root of 70 all over. Again, it's going to be the square root of 100. But in the grand scheme of things, it's really just going to reduce to a 10. And I'm going to have 3 times the square root of 70.
I thought they were, but maybe they weren't in there.
Now, moving on to where if I have a fraction. Okay, what I would suggest is anytime you have a fraction is to split it up. Now, if both parts are underneath the fraction, then whatever's underneath the radical can combine either by multiplication or division and simplify that way. Okay, what I would suggest in doing is if I do this, if I have the square root and 7 times 2, I multiply the top and I have 14, and then the bottom I have 15. Now, you want to separate this out to where it's the square root of 14 over the square root of 15. Okay. Now I can just rationalize it just like normal, so I'm going to go square root of 15 over the square root of 15, because it cannot have a radical in the denominator spot. 14 times 15 is the square root of 210. The bottom side is going to be 225, which is just going to be 15. Okay. Hopefully you start to see that of your problems, that anytime I multiply the same number that's underneath the radical, it's just going to be that number. Okay. Now, in some cases, you may not have to, like if I multiply straight across, you may not have to do anything. So, square root of 2 over the square root of 9, well, this is a perfect square, so all I'm going to do is just go square root of 2 divided by 3. If it's a perfect square in the denominator spot, then just take it as is and go from there.